Thus far, we have seen filter type feature selection algorithms. Filter type feature selection algorithms assess the relevance of features based on their individual characteristics independent of any specific machine learning algorithm. They rank or score features using statistical measures or heuristics such as correlation, mutual information, chi-square test, or variance threshold. So features are selected or discarded based on these rankings or scores. Examples of filter type feature selection algorithms we have seen, which include information gain, variance threshold, chi-square test. So now let's move on to the wrapper type feature selection. Wrapper type feature selection algorithms evaluate the quality of features by training and evaluating a specific machine learning algorithm. They use the performance of machine learning algorithm on different feature subsets to determine the relevance of features. So wrapper type algorithms perform a more exhaustive search of the feature space but can be computationally expensive. So examples of wrapper type feature selection algorithms include recursive feature elimination, forward selection, backward elimination. So we will deep dive into the recursive feature elimination. So that's what we will be seeing first. So recursive feature elimination, and we also call it as RFE, is an iterative feature selection method used to identify the optimal subset of features by repeatedly training and model and eliminating the least important features. So first let's define and explain what is RFE. So RFE is a backward feature selection technique that starts with all the features in the dataset and recursively eliminates the least important features until a desired number of features or predefined stopping criteria is reached. So the importance of features is determined by their impact on the model's performance, which can be measured using various metrics specific to the chosen algorithm. So now let's look into the applicability to the data type. RFE can be applied to both single sample and multi-sample datasets. It's commonly used in supervised machine learning problems where the goal is to predict a target variable based on a set of input features. So RFE is applicable to a wide range of algorithms, including linear regression, logistic regression, support vector machines, random forests, and gradient boosting. So, so how do we do it? Do we use any formula to do recursive feature elimination? So, the RFE algorithm does not have a specific mathematical formula. Instead, it follows a step-by-step iterative process. So let's look into the general outline of the RFE procedure. So in this recursive feature elimination process, we will begin with initializing the algorithm with all the features in the dataset. Then we will train the model using the chosen algorithm on the full feature set. Assign importance scores to each feature based on their contribution to the model's performance. Then eliminate the least important features based on the assigned scores. Then obviously you have to repeat steps 2 to 4 until a desired number of features or stopping criterion is reached. It's nothing but you have to keep on repeating. So you have to train the model using the chosen algorithm on the full feature set, then assign importance scores to each feature based on their contribution to the model's performance, and eliminate the least important features based on the assigned scores. And you have to repeat this until you reach a desired number of features or stopping criteria. So, and the final subset of features is considered the optimal feature set. Okay, so now let's look into some of the applications where this can be applied very well. So RFE is widely used in various real life applications, including biomedical research, identifying the most relevant biomarkers or genetic features for disease diagnosis or prognosis, and financial analysis, selecting the most significant variables for predicting stock prices or credit risk assessment, image processing, identifying the most informative features for image classification or object recognition tasks. Then natural language processing, selecting key features for sentiment analysis or text classification tasks. Then we have our customer relationship management CRM, identifying the critical features for customer churn prediction or market segmentation. These are the fields where we can apply the recursive feature elimination to do the feature selection using this method. So now let's move on and we'll see some real world examples where we can apply this method, where we can apply this algorithm to do the feature selection. So let's begin with cancer diagnosis. So in medical research, RFE can be used to identify the most relevant genes or genetic markers or for classifying cancerous cells from healthy cells. Similarly, we have credit risk assessment. So RFE can help select the most predictive features for determining credit worthiness, such as income, credit history, and employment status. And the third one that we have here is NLP, so natural language processing. RFE can be applied to feature selection in text classification tasks, identifying the most informative words or engrams of sentiment analysis or topic classification. Then we have the predictive maintenance. So task here, RFE can assist in selecting the most important sensor measurements or variables for predicting the equipment failure or maintenance needs in industrial settings. So overall, recursive feature elimination is a powerful feature selection algorithm that iteratively removes less important features, allowing for improved model performance, reduced dimensionality, and enhanced interpretability.